now we're going to talk about bonding. Bonding is the joining of two atoms or more together, and they can be joined in a lot of different ways. We're going to go through them from the strongest type of bonding to the weakest type of bonding. However, in biology, you'll see there might be some differences in how that works. But if you join an atom and an atom together, you get what we call a molecule. And molecules are represented by the elements that are part of that molecule. In this case, sodium chloride is sodium, one-to-one relationship between sodium and chlorine. In other words, in a molecule, you're going to have one of each of them together, and it is they're drawn or written where they are close to each other in writing. All right. So we're going to go over the first kind of bonding. The first kind of bonding is ionic bonding. Ionic bonding is where you have attraction between oppositely charged ions, and usually that forms a crystalline structure where you have opposite charges that are going to alternate, in other words, positive, negative, in the structure, and it will build into a crystal. So you might remember that salt is a crystal. You might have seen it in, like if you looked at salt really closely, you might have seen little blocks of the pieces of salt. But anything that's a crystal, generally, I shouldn't say anything, but generally things that are crystals are created by ionic bonding. Okay, so we're going to talk about how that happens. Okay, so first we have to talk about the creation of an ion. So I've written everything here. Normally I would write this like as we go so you can kind of see the progression of things. But let's just talk about it kind of close here. So we're going to make ions of sodium and chlorine. And let's just talk about sodium first. So if we look at the sodium atom, we have sodium is plus 11 protons in that central core. That means in the first energy level, it's going to have 2 electrons. Now, the Lewis dot writes them close together. Remember, in reality, they'd be on opposite sides of the s orbital, but we're just trying to keep track of the number of electrons, so we don't really need to write how they would literally exist. Okay, so in this case, there's 2 in the first energy level. In the second energy level, there's 8, the maximum of 8 in the second energy level, making up a total of 10. So 2, 4, 6, 8, plus those 2, that's 10. That means that we have 1 valence electron, right? So its charge normally would be plus 11 in the central core, negative 11 electrons. That gives its overall charge of nothing, right? That is in its pure form, it would not have a charge. Now, if it ionizes, and we'll talk about why it would in a minute, that will change, all right? So let's talk about chlorine first, though. So looking at chlorine, which would be next door to that sodium, chlorine has, oops, it should have been plus 17, not negative 17 there. We'll write that in. Oops. Sorry. All right, so that should be plus 17. That means that it's got 17 protons in that central core. In the first energy level, then it's going to have 2 electrons, just like always in that first energy level. The second energy level, it will have 8, so 2, 4, 6, 8. That makes a total of 10 so far. That means we have 7 valence electrons, 2, 4, 6, and the 7th valence electron. Now what's going to happen is, of course, its overall charge then would be in its original form, plus 17 and negative 17, or no charge for the original form. What will happen then is, because there is 1 valence electron here in that sodium, and this outside valence shell then only has 1 electron, so that's fairly unstable. Unlike this valence shell, which almost has 8, and 8 turns out to be a fairly stable configuration, regardless of if it's a sublevel or a full level. And so what's going to happen is that electron will go over here and join this side, okay? And when that happens, there is less electrons over here. So what that means is there's now still plus 11 in that central core, But negative 10, because we lost an electron instead of negative 11, that means its overall charge is +1. This creates an ionized version of sodium called an ion, or because it's a positive charge, it's called a cation. All right? Now over here, because the electron went over here, we now have an extra electron. So we have negative 18 instead of negative 17. That gives it an overall charge of -1. This is the ionized form of chlorine that created an ion of chlorine called an anion because it's negatively charged. All right? Now you have two charged particles or ions that can then form an attraction called the ionic bond. So the ionic bond is the attraction between the ions. So until then, we didn't have the ionic bond. Now we do. All right, so again, backing up, an ionic bond is the attraction of oppositely charged ions. So you have to first create those ions, okay? Now the next kind of bonding is covalent bonding. Covalent bonding in biology is very stable, all right? We will talk about why in a bit, but atoms in covalent bonding share electrons in an orbit to make their outer or valence shell stable. So a nonpolar covalent bond is one of equal sharing. We'll talk about polar covalent bonding in another segment. All right, so nonpolar means they have roughly equal sharing of electrons between the atoms in question. The example that we have here is methane. Methane is written CH4. That means we have one carbon atom and 4 hydrogen atoms making up this molecule. Now, for carbon, we have +6 in the central core. That means we have 2 electrons in the first energy level and 4 single electrons in the next valence shell. Now, in the case of hydrogen, we had +1 in the central core. That means we have 1 electron in its valence shell. In this case, hydrogen and carbon are going to share an orbit. When it does that, that gives this one 2 sometimes, and this one 2 sometimes, and that is more stable for both of them. And likewise, this is happening, that's happening, that's happening. And for all 4 valence electrons for carbon are then going to be full. So carbon is likely to join 4 or make 4 covalent bonds between something, and in this case it's hydrogen, and that's roughly equal sharing of electrons. It's often written like that. All right. Now another type of equal sharing of electrons is something. This is called a single covalent bond because each of those joiners are singly joined. Now this is a double covalent bond. This is oxygen. I forgot to write that in. It is O2, okay? And oxygen is, remember, +8. So we have +8 in that central core. And we have 2 electrons in the first energy level. And then that means that we have 6 in the next energy level. So 2, 4, 5, 6. And same thing for the other one. And it's going to make a sharing of electrons between those 2. This makes them both more stable configuration, and this is written like that. This is called a double bond. All right.